This is an epic sight that space travelers may enjoy as they approach CW Leonis, a pulsating red giant that has been thrashing in death agony for thousands of years. It is a scarlet ball of white-hot plasma that is enjoying its last moments of life. A cold vacuum erases its prominence. In its agony, two potent powers struggle in its depths. They now force the star to expand to dozens of times its size, then make it shrink again, only to flare up with new energy. One of these transformations is going to be the last one, but no one can predict the exact instance with any certainty. Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. If we hypothetically position the majestic star CW Leonis in the center of our system, its surface would submerge all planets, including Mars, and even brush the inner boundary of the asteroid belt. The radius at its pulsation peak may reach 560 times that of the Sun, which is approximately 2.6 times the distance from Earth to our apparent star. Interestingly, the star has a mass of only 1.5 to 4 solar masses. Like other red giants, CW Leonis is nearing the end of its life cycle, with an estimated age of several billion years. It is said that, during its solid days, CW Leonis was a white-blue star with a mass 3 to 5 times that of the Sun. However, by a billion years ago, a significant portion of the celestial body's hydrogen had burned out and transformed into helium, which slowly settled in the star's center. The helium then ousted all the remaining hydrogen and formed a scorching hot core that did not participate in any thermonuclear reactions. This process begins with a star's evolution into a red giant, which is common for all stars with masses near the Sun. The star's internal pressure leads it to expand to enormous dimensions, making the outer layers more rarefied and unstable. The space object gradually takes on a blood-red tint as its diameter increases by dozens of times. At some point, the pressure and temperature of the stelloplasma rise because of a thermonuclear process that is still occurring in the star's depths. This starts a nuclear fusion chain reaction that turns helium nuclei into carbon. This phenomenon, known as the helium flash, is a multifaceted, intricate physical process that causes a significant alteration in the star's internal structure. Rather than intensely heating up, the outer layers of the star cool and darken. Although CW Leonis has a lot of carbon right now, it lacks enough mass to reach the next stage of nuclear synthesis, making the thermonuclear combustion in its interior unstable. We assume that the occasional changes in the star's luminosity stem from this cyclic process. CW Leonis has a 649-day pulsation cycle, and at its peak, it is 11.3 times brighter than the Sun. At its lowest, the object emits 6,250 times more energy than the Sun at the moment of contraction in the upper layers of the stellar matter. Under the influence of gravitation, the stellar matter gradually cools and shrinks, causing the star's interior to heat up again and unleashing a fresh force of reactions. According to some estimates, as a result of this process, CW Leonis loses 4 times 10 to the power of 22 tons of material annually, which amounts to approximately 7 times the mass of the Earth. Observations reveal that the circumstellar nebula is not less than 69,000 years old, has a mass of about 1.5 times that of the Sun, and has a size of 84,000 astronomical units. Matter partially detaches from the star, forming a carbon-oxygen gas nebula that surrounds it. The complex structure of the nebula includes half-arcs, irregular rings, bulges, and pockets of gas. We hypothesize that the nearby unstable star's magnetic activity and stellar wind produce these formations. Explorers are deeply interested in the chemical composition of the cloud that shrouds CW Leonis. Spectral analysis data reveals it contains approximately 70 different chemical compounds, including iron, water, and carbon dioxide, among others. Although attempts to detect its radiation have been unsuccessful, some small red dwarfs orbiting the giant may be responsible for these phenomena. The nearby nebula may disperse and reflect the energy flow from nearby light sources, thereby camouflaging any nearby objects and preventing detection. Planets may have once existed on CW Leonis, but they seem to have vanished at an early stage of expansion. Regardless, years of observations did not reveal distinct traces of their existence in the past. In 1994, the star's orbit underwent subtle changes, and more recently in 2017, the cloud of gas and dust surrounding the star experienced mysterious shifts. It was initially thought that the star would melt and swallow up icy comets as it expanded, but observations made in 2009 revealed that some spectral lines reached a temperature of 1000 Kelvin, which is only possible if water vapor forms in the upper layers of the giant. This finding did not fit in with the accepted model of the red giant structure at the time, which states that all oxygen and stellar matter required for water synthesis must exist in the star. A novel theory emerged to explain the observed events. It claimed that strong UV light destroys carbon and silicon oxide molecules, releasing oxygen that then interacts with hydrogen to produce scalding hot water vapor. This hypothesis's flaw is that it doesn't explain the source of UV light. Reactions like this can only occur in star matter at very high temperatures, where it is essentially immune to cosmic rays. Another explanation for this paradox could be the star's instability. Raptures and low-density areas occasionally occur on its surface where ultraviolet radiation is not blocked out. Effectively, the water vapor's overall mass in the star's atmosphere and outer layers is estimated at several quintillion tons, though this figure may seem enormous. In fact, water accounts for just around a billionth of the star's raw mass, according to today's notions of stellar evolution. Being a red giant, CW Leonis is in its autumn years now. It will deplete its stellar fuel in the next 10 to 30,000 years, after which it will discard its outer layers following a powerful explosion. It will transform into an incredibly hot and dense space object, a white dwarf. Its mass will be roughly 80% that of the Sun, and its temperature will reach several million degrees in the first seconds after the transformation. However, with no energy source, it is destined to slowly and irrevocably fade in the course of billions of years to follow. Eventually, the celestial body will be almost invisible against the background of cosmic emptiness when it becomes a mysterious black dwarf. But this will not happen anytime soon. The shockwave and the mind-boggling temperature in the epicenter will generate new elements that are not to be found in a star's interior. For example, uranium, gold, and lead. They will later become part of new celestial objects millions of years later. Yet, radioactive decay will heat the planet's interiors. Global cataclysms and destruction are an unavoidable part of the universe's ongoing evolution, yet at the conclusion of every storm, there are new rays of light, music. The melting of ice and the saturation of the oceans with tiny elements create the conditions for the birth of life. In conclusion, the story of CW Leonis, the pulsating red giant, is a testament to the dynamic and evolving nature of the cosmos. Its spectacular display of celestial mechanics, from its dramatic pulsations to its eventual transformation into a white dwarf, offers a glimpse into the life cycle of stars and the profound impact they have on the universe. As CW Leonis approaches the twilight of its existence, it serves as a reminder of the impermanence of even the most massive and majestic objects in the cosmos. Yet, its legacy will endure long after its final pulsation. The elements forged in its fiery depths will contribute to the formation of new celestial bodies, perpetuating the cycle of creation and destruction that shapes the cosmos. Moreover, CW Leonis invites us to contemplate our place in the universe and the mysteries that still elude our understanding. Its enigmatic behavior challenges our current models of stellar evolution and inspires new theories and observations. Ultimately, the tale of CW Leonis reminds us of the awe-inspiring beauty and complexity of the cosmos, encouraging us to continue exploring and seeking knowledge of the vast expanse beyond our world. The saga of CW Leonis encapsulates the grandeur and intricacy of the cosmos, offering profound insights into the life and death of stars. Its pulsating red glow serves as a beacon for astronomers, inviting them to study its every nuance and unravel the mysteries of stellar evolution. As CW Leonis reaches the twilight of its existence, its imminent transformation into a white dwarf symbolizes the cyclical nature of the universe. From its birth in a fiery crucible of hydrogen fusion to its eventual demise as a cooling remnant, CW Leonis embodies the cosmic dance of creation and destruction that has shaped the cosmos for billions of years. Furthermore, the story of CW Leonis underscores the dynamic interplay between celestial bodies and the fundamental forces that govern their behavior. Its pulsations, nebula formation, and eventual collapse offer a wealth of data for scientists to deepen their understanding of astrophysics and cosmology. Beyond its scientific significance, CW Leonis inspires a sense of wonder and awe in all who gaze upon it. Its celestial spectacle reminds us of the vastness of the universe and our humble place within it, encouraging us to contemplate the profound questions of existence and our connection to the cosmos. In the end, as CW Leonis fades into cosmic obscurity, it leaves behind a legacy of discovery and exploration. Its story serves as a testament to the enduring curiosity of humanity and the boundless potential for discovery that awaits us among the stars. Thank you for watching.